In this lesson, we want to review the definition of a rational expression. We also want to talk about finding the restricted values for a rational expression. So before we jump in and start talking about how to find the restricted values for a rational expression, we want to think about the definition of a rational expression. And to properly do this, let's recall the definition of a rational number. So at the beginning of our course, we reviewed the definition of a rational number. We said that it was any real number that could be formed as the quotient of two integers where the denominator was not 0. So something like the number 1/4. 1 is an integer, 4 is an integer, so you have the quotient of two integers, the denominator is not 0, so that's a rational number. Something like -7/5, something like 11/14, something like just the number 10, right? 10 could be 10 over 1, right? So all of these fit that description. The main thing to understand here is that we can't divide by 0, so we can't have 0 in the denominator. Okay, so that's very important. Now, we think about these as rational numbers, but more practically, we just call them fractions. So in algebra, we have an algebraic fraction. This is known as a rational expression. And what this is this is the quotient of two polynomials where the denominator is not 0. So something like 3x minus 1 over, let's say, 5x squared plus 2. One polynomial over another. So that's a rational expression. As another example, let's say you had 2x squared plus 5x minus 1 over, let's say, 3x to the 4th power plus x plus 7. Okay, so you have a polynomial up here, a polynomial down here. So one polynomial divided by another, again, that gives us a rational expression. So essentially, when you start working with rational expressions, the first topic you come across is how to find the restricted values for a rational expression. Now, this topic just basically deals with division by 0. We know that we're not allowed to divide by 0. If we see something where we have division by 0, it's considered undefined. So something like 3 over 0, let me make that 3 a little better. This is undefined. Okay, that would be your answer there. In the case, and I know some of you will be confused and say, no, 3 over 0 is 0. That's not right, right? When you divide 0 by a non-zero number, you get 0. So 0 divided by 3 would be 0, okay? You can divide 0 by anything you want except 0. You get 0. But if you try to divide by 0, it is undefined, okay? So if I had a rational expression like x plus 7 over x minus 5, what would be my restricted value here? Well, it's anything that makes the denominator 0, okay? So if I look at my denominator, it is x minus 5. So how do I find the value for x that makes this denominator 0? All I need to do is set my denominator equal to 0 and just solve, right? What am I doing? Something minus 5 gives me 0. I'm going to solve for that something so that I know what I can't plug in for x. It's just that simple. So very easy. We just add 5 to each side of the equation. This will cancel. We'll have x is equal to 5. Okay? And you can easily see if I let x be equal to 5, let's say that we let x be equal to 5, plug in a 5 here and here. So you would have 5 plus 7 in the numerator, which is 12, over the denominator would be 5 minus 5, which is, of course, 0. And again, this is undefined. Undefined. And this is what we're trying to prevent. We don't want to end up with something that's undefined. So what we do when we have a rational expression is we find our restricted value or our restricted values, depending on how complex your rational expression is. And we just put a little note here. We say that this is defined for everything except for x when it's equal to 5. So we'll put x cannot be equal to, or x does not equal 5. Okay? A fancier way to do this is to state the domain. Okay? So the domain, in case you haven't seen anything with functions yet, and we'll talk more about this later in the course, the domain is the set of allowable x values. So what is allowed to be plugged in here for x? Well, everything in terms of real numbers can be plugged in for x except for 5. So the domain, or again, the set of allowable values for x, we'd say the set of all real numbers, or the set of all elements x, such that x does not equal the number 5. Okay, so anything you want to plug in for x there is fine, except for 5, because it makes the denominator 0. All right, let's look at another example. So we have 9x minus 1 over 3x minus 4. Again, all we need to do to find the restricted values, we take the denominator here and we just set it equal to 0. So we're going to solve 3x minus 4 equals 0. To solve this, I add 4 to each side of the equation. That cancels. I would have 3x is equal to 4. Divide both sides of the equation by 3. And I would end up with x is equal to 4/3. Okay? So again, I can write, comma, x does not equal 4/3. Or I can do it in the fancy way. So I can say my domain, okay, my domain is the set of all elements x, and then such that x does not equal 4/3. Okay. All right, let's look at another one. So we have 2x squared plus 7x minus 4 over 3x squared minus 21x. So again, I'm only concerned with the denominator here. So I'm just going to set this equal to 0, and I'm going to solve it. Now, you can get super complicated things in your denominator. This guy right here is not complicated at all. We can solve it by factoring. In case you're not familiar with solving something by factoring, the first thing you would do is factor this guy. So we can see that we have a common factor of 3x. We can pull that out. So if we pulled out 3x, I would have an x minus 7 here, and this is equal to 0. Now, what I'm going to do to solve this using factoring, I'm going to set each factor equal to 0. So I'm going to set 3x equal to 0, and I'm going to set x minus 7 equal to 0, and I'm going to solve each one of those. Now, why does that work? We have something known as the zero product property. So if you have something like a, and it's multiplied by b, and it's equal to 0, well then one of these statements has to be true. A is equal to 0, b is equal to 0, or both a and b are equal to 0. So in other words, we know that multiplying by 0 gives me 0. So it could be true that a is 0 and b is not. It could be true that b is 0 and a is not. And it could be true that a and b are both 0. So that's the premise behind the zero product property. And essentially all I'm going to do here is just set 3x equal to 0 and solve. Divide both sides by 3. I get x is equal to 0. I'm going to set x minus 7 equal to 0 and solve. Add 7 to each side of the equation. I get x is equal to 7. So we have two solutions here, and thus two values we need to restrict from our domain. So if I plugged in a 7 for x, or if I plugged in a 0 for x, I would get 0 as a denominator. And I think we can see that, right? If you plugged in a 0 here and here, you would have 3 times 0 squared minus 21 times 0. 0 squared is, of course, 0. 0 times 3 is 0. Minus 0 times 21 is 0. 0 minus 0 is 0. So the denominator would be 0 if you plugged in a 0 for x. Okay, so we see that. Also, the denominator would be 0 if you plugged in a 7. 7 squared is 49. 49 times 3 is 147. So you'd have 147 minus 21 times 7 is also 147. So you get 147 minus 147, which is 0. So we're going to write that x cannot be 0 and x cannot be 7. Let me kind of scooch these up. I'll scooch this up. So I'll put a comma here, and you can put a comma there if you want. So again, all real numbers are allowed except for 0 and 7. So we can write this again in this kind of fancy way. The domain is the set of all elements x such that x does not equal 0 or 7. All right, let's take a look at one more. So very easy concept overall. The only thing that can make it more difficult is the tediousness of the denominator, right? If you get something that's super complex, it might not be so easy to solve. You can't solve everything with factoring. You might have a very, very difficult denominator to work with. But for this, I'm just trying to show you the concept, so I gave you things that are pretty easy. So we have 2x minus 5 over 2x squared minus 9x minus 5. I'm just going to set, again, this guy right here equal to 0. So 2x squared minus 9x minus 5 equals 0. So here, we're not going to factor out the greatest common factor. We're going to factor this into the product of two binomials. So I'm going to do this using reverse FOIL. And the reason I'm going to choose reverse FOIL is because this coefficient here, this 2, is a prime number. So I know this would be 2x and this would be x. I just have to work out the correct outer and inner, right? So I know that I want a product of -5. So that can only come from 5 times 1 with the signs being different, right? So I got to have either -1 times 5 or -5 times 1. So knowing that I have a middle term of -9x, I'm going to want to multiply 2x by -5, and I'm going to multiply x by +1, right? 2x times -5 would give me -10x, and then 1 times x would give me 1x. 1x plus -10x would be -9x. So we factored this one pretty quickly. All right, so now I'm just going to set each factor. This is a factor, and this is a factor, equal to 0. So I would have 2x plus 1 equal to 0, and I would have x minus 5 equal to 0. So let me kind of slide this out of the way so we have a little room. So for this guy, let me kind of scooch this down. So for this guy, I'm going to subtract 1 away to start. So this cancels. I would have 2x is equal to -1. Divide both sides by 2, and you would get that x is equal to -1/2. For this guy, just add 5 to each side of the equation. Very simple. You get x equals 5. So let me erase everything. Kind of scooch these over. So we'll say x does not equal -1/2. And also x does not equal 5. Okay, let me make that a little better. So we can again write this using our domain statement. So domain is, let me make that better, the set of all x such that x does not equal to, you have -1/2 and then 5. In this lesson, we want to review writing rational expressions in lowest terms, otherwise known as simplifying rational expressions. So before we jump in and start talking about how to simplify a rational expression, let's just quickly review the process with fractions. So if I wanted to simplify 5/20, what could I do? Well, kind of the easiest way to do it, the way that I do it right now, I eyeball these things and say, okay, what's the greatest common factor between 5 and 20? I know 5 is a prime number. I know 20 is 5 times 4, or 5 times 2 times 2. So I can just divide the numerator and denominator by 5, right, the GCF. 5 divided by 5 is 1. 20 divided by 5 is 4. So it's 1/4. But the more technical approach to this would be to factor the numerator and denominator completely. So 5 doesn't factor. I'm just going to write it as 5. 20 would factor into what? It's 5 times 4, or 2 times 2. And then I would cancel any common factor that's not 1 between the numerator and denominator. So I'd cancel this 5 with this 5. Go ahead and write a 1 there. And I'd end up with 1 over 2 times 2, which is 4. So my simplified answer here is 1/4. Now we're going to use the same thought process when we simplify rational expressions. If I have something like 2x squared plus 7x minus 4 over 5x squared plus 20x, all I need to do is factor the numerator and denominator completely and then cancel any common factors. Now, before we begin, I want to make something absolutely clear. If you cancel things here, you got to understand that you can only cancel common factors. This is very, very common as a source of confusion. So if you have something like a multiplied by b over a and b here in the numerator are factors. They're multiplying each other. This can cancel with this, okay? I'm just left with b. So if I had something like 2 times 3 over 2, the 2's will cancel. I'm left with 3, okay? Very easy to understand that. Where students get confused is they have addition involved and they try to cancel. If you see something like 2 plus 3 over 2, you cannot cancel this, okay? Please don't do that. That's wrong. It's a very common mistake. You cancel common factors, okay? So this is wrong. So as an example, let's say you had something like x plus 5, this quantity, multiplied by x minus 1. These are factors. X plus 5 is a factor, x minus 1 is a factor. So this is a factor, and this is a factor. If this is over x plus 5, this quantity, times x minus 3, again, this is a factor, and this is a factor. So I cancel common factors, right? This and this can be canceled. They are factors. They can be canceled. But if I had something like, let's say, x plus 5 plus 1 over, let's say, x plus 5 plus y or something like that, you see students try to cancel this and this. This is addition. This is addition. You can't cancel, okay? It's got to be canceling common factors, okay? That's what we're looking for. So please don't get confused between those two. Now, what am I going to do here? I'm just going to factor this numerator into the product of two binomials, and I'm going to factor the denominator into a monomial times a binomial, okay? And then I'm going to look to see if I can cancel anything. So for the numerator, I'm going to use reverse FOIL here because it'll be a little bit quicker because this guy right here is a prime number. 2x squared can only come from 2x times x. So this will be 2x times x. Now I just need to work out this 7x part, okay? To do that, I think about factors of -4. We've got 1 and -4 or -1 and 4, right? So 1 and -4 or -1 and 4. You also have 2 and -2, but that won't work. Why won't it work? Remember what we talked about in our lesson on reverse FOIL. If I put in a -2 here and a +2 here, or reverse that, it doesn't matter, you would have a common factor of 2 here. There's no common factor of 2 in this guy. So this doesn't exist, right? This can't be possible. So we'll erase this and just focus on this scenario. Now, I have 7x. I know that that could come from 2x times 4, which would give me 8x. And then x times -1 would give me -x. 8x minus x would be 7x. So I would want a 4 here, right, because I want 2x times 4. And I would want a -1 here because I want x times -1, right? So again, 8x minus x would give me 7x. So that's our factorization. All right, down here it's very, very easy. We pull out the GCF, which is 5x. Inside the parentheses, we're left with x plus 4. Now, again, I can't stress this enough. This is multiplication. This is multiplication. The quantity 2x minus 1 is multiplied by the quantity x plus 4. These are factors. Okay, these are factors. And then these are factors. Okay, these are factors. So 5x is multiplied by the quantity x plus 4. We can cancel common factors. You have x plus 4, you have x plus 4. That can be canceled. Okay? So what am I left with after I cancel? I'm left with 2x minus 1 over 5x. Okay, so this is the simplified version. When you work with rational expressions, as we talked about in the last lesson, you deal with restricted values. You can't divide by 0, so any value that you replace the variable with that results in a denominator of 0 has to be restricted from the domain. If I look at the simplified version here, if I plugged in a 0 there, obviously 5 times 0 would give me 0. So I would say x does not equal 0, but that's wrong. X can't equal 0, but x also can't equal -4. And the reason x can't equal -4 is we have to think about this in terms of the original rational expression. With the original rational expression, if I factor the denominator, I have 5x multiplied by the quantity x plus 4. We know 5x being set equal to 0 would give me a result of x equals 0. So we've already restricted that. We found that. We're done with that. This part right here, the x plus 4 that canceled, we lost that information. So x plus 4 equals 0. If I subtract 4 away from each side, I get x equals -4. So that's also a restricted value. X can also not be -4. So don't let that trip you up. When you're stating restricted values, always go with the original rational expression, not the simplified one, because the simplified one will lose information, okay? And you'll end up putting the wrong domain down. All right, let's take a look at another one. So we have x squared minus 4x minus 12 over x squared minus 4. So very easy to factor this guy. So for the top, I want two integers whose sum is -4 and whose product is -12. So this is x and this is x. For -12, I would immediately think about -6 and +2, right? -6 and +2. And of course that would work out, right? Your outer would be 2x and your inner would be -6x. -6x plus 2x would give me -4x. So that's good to go. For this guy, x squared minus 4, it's the difference of two squares. So we talked about this. This factors into x plus 2 times, you'd have x minus 2, right? whatever squared here minus whatever squared here. This is basically x squared minus 2 squared. Okay, so that's how we get this. So I can cancel this with this, right? X plus 2 in the denominator with x plus 2 in the numerator. Again, if you're thinking about the domain, think about it in terms of the original rational expression. If I write this as x minus 6 over x minus 2, I've lost the information that this guy presents, right? Because here I know that x can't be negative 2, and I know that x can't be positive 2. With this guy, I know that x just can't be 2, right? So I'm just going to go ahead and write that x does not equal 2 or negative 2. All right, let's take a look at another one, and this one's a little bit more tedious. So we have 21x squared plus 123x plus 90 over 3x cubed plus 17x squared plus 10x. Now, in the numerator, I am going to pull out a 3 to start. That would give me 7x squared plus 41x plus 30. And I'm just going to work on this for now. I'll come back to the denominator in a minute. So to factor the inside here, I'm going to go ahead and use reverse FOIL since 7 is a prime number. So 7x, and you'd have x over here. I'll put my 3 outside. So I need to figure out some factors of 30 here. So 30 factors into what? It's 6 times 5. 6 is 3 times 2. Okay, so I have some possibilities here. So to go through the possibilities, we have 1 times 30. We have 2 times 15. We have 3 times 10. We have 5 times 6. And that's basically it. Now, 1 and 30 won't work. 2 and 15 won't work. 3 and 10 won't work. But 5 and 6 would work. 7 times 5 is 35. And 6 plus 35 is going to give me 41. Okay? So that's the factorization there. Let me erase this. I don't need that anymore. So let me see if I can squeeze this in here. Hopefully I can. 3 times the quantity 7x plus 6 times the quantity x plus 5. All right, for the denominator, I can pull out an x to start. That would give me 3x squared plus 17x plus 10. And then for this part right here, again, I'm going to use reverse FOIL because this guy's prime. So 3x and x. That's the only way you can get 3x squared. So I need to figure out how to get a middle term of 17x. And the factors of 10, you've got 1 times 10, you've got 2 times 5, and that's it, right? So if I want 17, I could multiply 3 times 5 and get 15. And I could multiply 2 times 1 and get 2. And 2 plus 15 would give me 17. So we would have x times the quantity 3x plus 2 times the quantity x plus 5. Okay. All right, let's drag this guy down here so we have a little room. So we can see that we have a common factor of x plus 5. Cancel this with this, and I'm left with 3 times the quantity 7x plus 6 over x times the quantity 3x plus 2. Now you can leave it in factored form just to show that there's nothing else that will cancel. That's very common. You could also distribute the 3 to each term here and the x to each term here. Both answers are valid. Now, in terms of the restricted values, you would have 3 of them, right? If you look at the original here, x can't be 0. So x cannot be 0. Right, I got that from this x here. Just set x equal to 0. 3x plus 2, we would set that equal to 0 and solve. So this would be 3x is equal to negative 2. Divide each side by 3. You get x is equal to negative 2/3. So x can also not equal negative 2/3. And then lastly, you have x plus 5 here, which was canceled. Again, we lose that information in the simplified version. So x plus 5, if you set that equal to 0, we subtract 5 away from each side of the equation. You get x equals negative 5. So x also can't be negative 5. So 3 restricted values there. You have 0 that can't be in the domain, negative 2/3, and also negative 5. All right, for the last problem, we're going to look at one that's a little bit challenging. So we have 2x squared minus 9x minus 35 over 2x cubed minus 15x squared plus 6x plus 7. So let's start by just factoring the numerator. So I'm going to use reverse FOIL here. This guy's prime, so it's going to be pretty easy. And I want to get a correct middle term of negative 9x. So I know that for 35, forget about the fact that it's negative. it's going to be 1 times 35 or 5 times 7. So I know 1 and 35 will not work, but 5 and 7 would work if I put a minus 7 and a plus 5. Because the outer term here, 2x times negative 7, would be negative 14x. In the inner term here, 5 times x would be plus 5x. You combine those, you would get negative 9x, okay? So that's what we're looking for there. Now, this is a 4-term polynomial down here. This 2x cubed minus 15x squared plus 6x plus 7. Pause the video and see if you can factor that using grouping. So hopefully you gave that a shot, and you'll notice that no matter what you do, you cannot factor this using grouping. Most people would just throw in the towel here and just say, okay, it can't be simplified. But you need to think a little bit deeper here. This is a very common problem as you get into more advanced courses. You'll be given stuff that doesn't factor using traditional methods. So we have to think about something else. If I have 6 times 3, and this gives me 18, well, I know 3 and 6 are factors of 18. 3 and 6 are also divisors of 18. Meaning if I divided 18 by 3, I get 6. If I divided 18 by 6, I get 3. So hopefully you can see where I'm going with this. If we can simplify here, then it must be true that this guy would factor into something that has one of these, right? So this could be a factor or this could be a factor. If neither of them is a factor, then we can't simplify. So all I actually have to do is do some division, right? I can do polynomial long division, or in this case right here, if this turns out to be a factor, we can use synthetic division. So we're going to start out with that because synthetic division is pretty quick. So this is in the format of 1x to the first power minus some number. So if it's in that format, just grab the number. So 7 is going to go out here. Just like I taught you in the review session, we're going to take the coefficients only. So my 2, my negative 15, my 6, and my 7. Okay? Let's put a little bar down here. Let me scroll down, get a little room. We'll come back up in a second. Drop down the first number. So this goes here. 7 times 2 is 14. We add, negative 15 plus 14 is negative 1. 7 times negative 1 is negative 7. We add, 6 plus negative 7 is negative 1. 7 times negative 1 is negative 7. 7 plus negative 7 is 0. This is important here. We have no remainder, okay? We have no remainder. So that means that x minus 7 is a factor of 2x cubed minus 15x squared plus 6x plus 7. And we have our answer right here from the division. So we know that this would be x minus 7 times, you would have what? It's 1 degree less, so it would be 2x squared, and then minus x, and then minus 1, okay? And if you don't believe me, go ahead and multiply these two together, and you will see that you get this back, okay? Again, all we did, just to go through this again, because I know some people will get confused, this guy right here divided by this guy right here gives me this guy right here. So this guy times this guy gives me back to this guy. So we just factored it using division. Okay, that's all we did. Now the question is, can I further factor this? Can I factor 2x squared minus x minus 1? So this would be 2x and this would be x. We have negative 1 here, so that's pretty simple. It's either plus 1 here minus 1 or the other way around. The outer here would be negative 2x, and the inner would be plus x. That's exactly what we want, right? So let's scooch this down. And let's slide this up. And we have successfully factored this guy as the quantity 2x plus 1 times the quantity x minus 1 times the quantity x minus 7. Now, we're going to go ahead and just cancel this with this, and we've simplified this guy. So it's 2x plus 5 over, you have the quantity 2x plus 1 times the quantity x minus 1. And again, we should leave this in factored form just to show that nothing else would cancel. If you want to look at the restricted values here, again, you go with the original one. This is in factored form, so if I was to set this equal to 0, right, the denominator, then I could just go through to each factor and solve that equation. So 2x plus 1 equals 0. Subtract 1 away from each side, you get 2x is equal to negative 1. Divide each side by 2, you get x equals negative 1/2. So x cannot be negative 1/2. The other ones are easy. You can just solve them by inspection. you have x minus 1. If that was equal to 0, x would just be 1, right? So 1, and then this guy right here, which we canceled, x minus 7. If that was equal to 0, x would just be 7. So just to state our final answer here, we have this 2x plus 5 in the numerator over the quantity 2x plus 1 times the quantity x minus 1. And then our restricted values, again, thinking about the original rational expression, x cannot be negative 1/2, it cannot be 1, and it cannot be 7. In this lesson, we want to talk about multiplying and dividing rational expressions. So in order to multiply and divide rational expressions, we need to think back to our basic math where we talked about multiplying and dividing fractions. So to get things started, let's just look at a very simple example, and then we will take this up a step and we'll think about rational expressions. So we have 1/4 times 2/7. How can we solve this problem? Well, basically what we could do is multiply across. So 1 times 2 is 2, and then 4 times 7 is 28. So basically numerator times numerator over denominator times denominator. But the problem with this is it's quite inefficient, right? If we just do this without trying to cancel anything, we end up with an unsimplified fraction. So we have to take the extra step now of simplifying, and basically you have a common factor of 2 there that you can cancel out. So 2 divided by 2 is 1, 28 divided by 2 is 14, so I get 1 over 14, okay, as my simplified result. Now, a more efficient way to do this, if we think about this, we would first make sure that each fraction, okay, in the multiplication problem is simplified already. So that means no common factors other than 1. So if I look at 1 and 4, we're good to go. If I look at 2 and 7, we're good to go. So nothing can be canceled there. Then I want to look to cross cancel. So in other words, I want to look here and I want to look here. Anything I can cancel? No. So then I want to look here and I want to look here. Anything I can cancel? Yes. 2 and 4 are both divisible by 2. If I divide 2 by 2, I get 1. If I divide 4 by 2, I get 2. Okay, so now once you've canceled everything, you can go through and multiply, and you're going to get a simplified result. So 1 times 1 now would give me 1, and 2 times 7 would give me 14. So now I have 1/14, and it's already simplified. So let's use the same strategy now when we're multiplying these rational expressions. We're going to think about simplifying each rational expression first, and then we're going to look to cross cancel. And once we've done both of those steps, then we want to move on and do some actual multiplication if it's necessary. In a lot of cases, so much stuff cancels, you don't even need to multiply. Now, before I actually do this problem, I want to make sure everybody's on the same page in terms of what can be canceled and what can't be canceled. This is quite confusing when you get into algebra. So if we have something like, let's say, 3 over 12, we know that we could write this as 3 over 3 times 2 times 2, okay? And then I can cancel this with this, right? I'm basically just saying 3 over 3 is 1, so I can cancel it out, right? So this ends up being just 1 over 4. Now, if you saw something like, let's say, 4 plus 3 over, let's say, 3, you should know, but you might not know, that you cannot cancel this 3 with this 3 like this. This is a very common error in algebra. You can only cancel common factors. If this was 4 times 3 like this, then you could cancel, okay? But if it's 4 plus 3 or 4 minus 3, you can't cancel. Think about this. 4 plus 3 is what? It's 7. 7 over 3 is not the same as if you canceled this and just got 4, okay? So please don't make that mistake. Now let's take this up a notch and think about this with something like this. Let's say I had x minus 1, this quantity, times, let's say, x plus 5, this quantity, and this was over, let's say, x minus 1 again, that quantity, and then times, let's say, x plus 6, this quantity. Now, a lot of people get confused here because you see there's a minus sign, a plus sign, a plus sign, a minus sign, and then when I start canceling stuff, they say, well, why can you cancel there? These are factors here, okay? This quantity here of x minus 1 is being multiplied by this quantity x plus 5. So these guys here are what we call factors, okay? They are being multiplied together. And so I can cancel common factors. So between the numerator and denominator, I have a common factor of x minus 1, so it can be canceled or removed. One way to see this for sure, let me just erase this real quick. If you thought about this, you could plug something in for x. You could just pick a number and plug it in. Let's say you picked 3, for example. Well, instead of x there, I would have a 3. Instead of x there, I would have a 3. Instead of x there, I would have a 3. Instead of x there, I would have a 3. Okay, so 3 minus 1 would be 2. So let's say we have 2 there. And then 3 plus 5 would be 8. So now we have 2 times 8. Here we'd have 3 minus 1, which is 2. Okay, we have 2. And here we have 3 plus 6, which is 9. So now it should be crystal clear to you that you can cancel this 2 with this 2, right? But where did that come from? That came from that common factor of x minus 1. So I hope that clears things up for you. Just pay close attention to what you're trying to cancel. It needs to be a common factor, okay? So with that being said, let's look at this first problem. We have 3x squared minus 2x minus 8 over 3x squared plus 14x plus 8. This is multiplied by 3x plus 2 over 3x plus 4. So again, what I want to do is think about factoring everything, simplifying between the rational expressions themselves, and then also trying to cross-cancel anything I can before I actually do any multiplication. So this guy right here and this guy right here, those are prime. You can't do anything with them. But for this one and this one, you can factor those, okay? So I'm going to use reverse FOIL here. If you're more comfortable with the AC method, that's fine too. So let's go ahead and set up some parentheses here. I'm going to do 3x and x because this is a prime number, okay? So that can only come from 3x and x. So all I have to do is work out what's going to go here and here. Now, I have 8 there. Forget about the fact that it's negative 8 for a moment and just think about 8. So 8 is 1 times 8 and it's 2 times 4. So 1 and 8, there's no way to make that work. But with 2 and 4, if you think about it, let's say you put a 4 here and a 2 here. Well, the outer would be 12x and the inner would be 2x. And don't worry about the signs just yet. This is not going to work, right? 12x and 2x, no matter how you play with the signs, that's not going to work. So let's think about the other configuration. Let's flip this. Let's put a 4 here and a 2 here. Well, now this would be 6x and this would be 4x, and I can make that work, right? If I made this negative and this positive, well, this would give me my negative 2x. And also, if I had a positive and a negative being multiplied together, I'd get my negative, okay? So what I want here is a negative here and a positive here, okay? So that would give me my 3x squared minus 2x minus 8. Okay, so moving on to the next one, let's go ahead and put our fraction bar. We have this guy here, so I'm going to factor it in a similar way. I'm going to do 3x, and I'm going to do x. And again, what's going to go here? Well, I have 8 once again, so it's only 1 and 8 or 2 and 4. So could I make this work with 1 and 8? Well, if I put 8 there, I would have 24x. That's going to be a little bit too big. If I put 8 here and 1 here, that's going to be too small. So 1 and 8, you can throw those out. That's not going to work. So if I put 4 here, I would have 12x. And then if I put 2 here, I would have 2x, so that looks like that would work, right? I want plus and plus, right? So the outer would be 12x, and the inner would be plus 2x, so that would combine to give me the 14x, and again, 2 times 4 is 8, so we're good to go there. So then let's multiply this by 3x plus 2 over 3x plus 4. So once you've factored everything, you've pretty much done, okay? This is the hardest part, or the most tedious part. If you're good at factoring, it's not hard at all. So let's come down here and see what we can cancel. Well, I have a common factor of 3x plus 2 here with here, okay? So if you're confused by this, you can always wrap this in parentheses and multiply it by 1. Okay, you don't have to do that. I'm just doing it to show you this. So you can cancel this with this. Those are, again, common factors. Then I'm looking at this 3x plus 4 and this 3x plus 4. So this cancels with this. So this right here is a big fat 1 now. It's completely canceled. So all I'm left with, if you want to solve this problem, is just take the x minus 2 over the x plus 4. And that's your simplified answer, okay? You don't need to do anything else. Things canceled, so you didn't even have to multiply. Okay, let's look at a more tedious problem. It's not harder, it's just more tedious. So we have x squared plus 9xy plus 14y squared over x squared plus 7xy plus 10y squared. This is now multiplied by x squared plus 2xy minus 15y squared over x squared minus xy minus 6y squared. Okay, so again, the first thing you want to do is factor everything and just try to cancel as much as you can. And if you have to, you're going to multiply. So what I'll do here, remember, these are meant to look scary, but they're actually not. So if you have an x squared here and a y squared here, just put an x and an x and a y and a y, right? X times x is x squared, y times y is y squared. Then forget about it. I'm going to do the same thing down here. So x, y, x, y. And if you want to, you can do this over here as well. So let's go ahead and set this up. So let's put these here, and I'll do x, 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 y, 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 y. And I'm sure those aren't going to be conducive to me fitting everything. So let me slide that down just a little bit more. And that might be too wide, but we'll adjust it as we need to. Okay, so for this one right here, it's really easy. Everything in terms of the leading coefficient is 1. So I'm just looking for two integers that sum to 9 and give me a product of 14. So that's 7 and 2, right? So plus 7 and plus 2, okay? Again, because you figured out that the y was there, you only have to work out this and this. That's it. So here, I've got 7 and I've got 10. So it's got to multiply to 10 and sum to 7. That's 5 and 2. So that's really easy. So 5 and 2. Here, it's got to sum to 2 and give me a product of negative 15. So that's going to be positive 5 and negative 3. So positive 5, and this isn't going to fit. So let's put x plus 5y and then x minus 3y. So positive 5 and negative 3. Okay, so for this one, we have negative 1, you could think of it as, and negative 6. So the product is going to be negative 6, the sum is going to be negative 1, so that's going to be negative 3 and positive 2. So negative 3 and positive 2. All right, let's see what we can cancel. So we have x plus 5y here that can be canceled with x plus 5y here. Again, we're canceling common factors, so things wrapped in parentheses. That's what we're looking for. X plus 2y here can be canceled with x plus 2y here. And then x minus 3y here can be canceled with x minus 3y here. Okay, so basically all you're left with is an x plus 7y. So let me scroll down and get some room so I can fit this. I'm going to put is equal to, I just have x plus 7y. That's my numerator. For the denominator, I'm just left with this x plus 2y. So again, in a lot of these cases, you don't even need to multiply because so much stuff's going to cancel. Okay, so we've done 2 with multiplication. Let's switch now to division, which is just as easy. So basically, we remember if we're dividing fractions, we keep the first fraction the same, we take the reciprocal of the second fraction, and then we multiply. So this guy is 6 over 11, so the first fraction stays the same. Change the division to multiplication, flip this guy, right? So the reciprocal, this goes up here, this comes down here. So I would basically have 33 over 4, okay? You can already see that this would cancel with this and give me a 3. This would cancel with this. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So this is going to give me what? It's going to give me 3 times 3, which is 9, over just 2, right? Because this is 1, it's been canceled. So this is 1 times 2, or just 2. So the answer there is just 9/2. Very simple process. And we're going to do the same thing here. So we'll look at the x squared minus 9x plus 14 over 2x squared plus 3x minus 5 divided by x squared minus 2x minus 35 over x squared minus 4x plus 3. So however you want to do this, the first thing I'm going to do is just factor this one on the left. So I know that this is what? This is negative 9 and positive 14. So I need two integers that sum to negative 9, give me a product of positive 14. That's going to be negative 7 and negative 2. So x minus 7 and then x minus 2. Okay, so I've got that one. This one right here is a little bit harder to factor because this guy is not 1, but it's a prime number, so it's pretty quick, right? So I'm going to put 2x here and x here. Now, this last term here is negative 5. I'm just going to think about 5 for a second. 5 is only 1 and 5. Okay, it's 5 times 1 or 1 times 5, however you want to think about that. Okay, so the only possibilities are to have, and forget about the signs for a moment, a 5 here and a 1 here, or to reverse that. If I multiply 2x times 5, I'm going to get 10x. That is too big, so it's not possible. So we'd have to put a 5 here and a 1 here, because this would be 5x, okay? And then this would be 2x. So that would work, I just got to get the sign right. And basically I want 5x to be the larger one, so I want a plus sign here and a minus here, right? So the outer would be negative 2x, and the inner would be positive 5x, so this would be your correct factorization. Now, what I'm going to do here is multiply it by, I'm going to flip this guy. So this is going to be my numerator, okay? My denominator becomes my numerator. So let's factor this guy. We'd have an x here and an x here. And so what I would do is look for two integers whose sum is negative 4 and whose product is 3. So you can go ahead and do negative 3 and negative 1. So minus 3 and minus 1. And then this is over. Again, this numerator here is now going to be the denominator here. So I'm going to factor this guy. So give me two integers. I'm going to put my x here, my x here. Two integers whose sum is negative 2 and whose product is negative 35. Well, you could do negative 7 and positive 5. So negative 7 and positive 5. Okay, so let's scroll down now. Again, all you have to do is just flip the second fraction, or it's flip the second rational expression. Everything else is just the same, right? You're just multiplying, so you're looking to just cancel stuff. So I can cancel this guy, x minus 7, with this guy, x minus 7. Those are common factors. I can cancel this factor of x minus 1 with this factor of x minus 1. And then, can I cancel anything else? Doesn't look like it. So in this case, we actually need to multiply. Now I'm going to tell you two different ways you can do this. In every case, you are allowed to just say something like x minus 2 times x minus 3. So those two quantities multiplied together and leave it as it is, okay? Some teachers will tell you to multiply the numerator out and leave the denominator factored. Some want you to have everything factored. You just have to check with your teacher to see what's required. Down here, I'm going to do this 2x plus 5, that quantity, times x plus 5, okay? And just for the sake of completeness, let's go through the process. And we're going to multiply everything. So x times x is x squared. The outer would be minus 3x. The inner would be minus 2x. And the last would be plus 6. So this would be minus 5x here. So minus 5x and then plus 6. This is over. The first would be 2x squared. The outer would be plus 10x. The inner would be plus 5x. And the last would be plus 25. So if you combine the like terms, you'd have plus 15x here. So basically, you could write this like this in the factored form, or like this where you've multiplied it out. Either way is an acceptable answer. All right, let's look at one that's very, very tedious. This is just a lot to do with factoring, and basically you have to be good at factoring to be good at this guy. So when I look at this problem, I see multiplication and then I see division, okay? So basically you want to turn this into one long multiplication problem. You're just going to flip this guy right here, okay? So basically what I'm going to do, I'm going to try to fit this all on the screen. So x squared minus y squared, we know this is the difference of two squares. So this is x plus y times x minus y, okay? So you can factor that. Then this guy right here, this x minus y quantity squared, remember, I can't say this enough. You cannot distribute that in. You have to expand this. This is the same as having x minus y times x minus y, okay? Now, it turns out that if you run through this, you're going to get this, right? So this is the expanded form, and this guy is the factored form. Really, you'd write it like this, okay? So let's see what we need to do with this before we expand it. We'll put x minus y. I'm just going to put quantity squared. So I'm just going to leave it as it is, okay? Then this guy right here, up here, we cannot factor this. This is -1 and this is +1, okay? So can you give me two integers that sum to -1 and have a product of +1? No, you cannot, right? It's not possible. So I'm going to leave this one up here as is. So x squared minus xy plus y squared. And this is over. This guy down here, which we already know is going to factor into this, right? If you expand this, you square the first guy. So that's how I get x squared. Then it's minus 2 times the first guy times the second guy. So I get minus 2 times x times y. Then it's plus the last guy squared. Okay, so this factors into x minus y quantity squared. Then I'm going to multiply by, I'm going to flip this guy. Now, this guy right here is the sum of cubes. So this guy is something you should remember how to factor. It's really convenient to remember how to factor it. I don't know if I can fit this all on the screen as of right now. So let me just write this in unfactored form. And then I'm going to go to the next screen down and we'll see if we can get this on here, okay? And then this guy right here, this is x minus y to the 4th power. So we're going to be able to cancel some stuff right now. That's going to give me some space. So you'll see here that you have x minus y, this quantity squared, basically multiplied by x minus y, this quantity squared. So you could write this out as x minus y times x minus y times x minus y times x minus y, okay? And you could write this out as the same thing. Realize your rules of exponents. You have the same base here. This is your base, okay? This is your base. So really, this is x minus y to the 4th power, okay? So those guys combined would cancel with this completely. This would cancel with this and this, okay? Again, if you wanted to write this part as x minus y, and this as x minus y times x minus y in each case, then you'd see that you have 4 of those, and you could expand that out to exactly this, and it would all cancel, okay? So that is gone. Now, the next part here, to go any further, let me scroll down a little bit and get some room. I'm going to write x plus y times x minus y. And then times, you have this x squared minus xy plus y squared. And then I'll put times, you'll have this 1 over. Let's go ahead and factor this now. So from my special factoring formulas, this is going to be x plus y. That's the first one. Then times, it's going to be exactly this. So x squared minus xy, and then plus y squared. So now what I'm going to do, I'm going to think about this again as a factor. So I'm going to cancel this with this, and then I'm going to cancel this with this. And really all I'm left with now is this x minus y, okay? So you can see on this type of problem, they just want you to really know how to factor in order to go through and just cancel, 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 until you end up with something very simple with just x minus y as your answer. In this lesson, we want to review finding the least common denominator, which is abbreviated as the LCD, for rational expressions. So we should know at this point that, again, working with rational expressions, we follow the same rules that we learned when we work with fractions. If we want to add or subtract fractions, we know we have to have a common denominator. Well, it's the same thing when we work with rational expressions. So in the next review session, we're going to talk about adding and subtracting rational expressions. So before we kind of jump into that, we want to review how to find the LCD, right? The least common denominator, all right? So the LCD when we work with fractions is found in what way? Okay, let's just refresh our memory. If we have 1/3, 4 over 21, and 5 over 36, again, the LCD is the LCM, or least common multiple, of the denominators. So 3, 21, and 36. Okay, so you might be really confused at this point because you hear all of these different acronyms, right? You hear GCF, you hear GCD, you hear LCM, you hear LCD. So what are all of these things and why does everyone get them confused? Well, the GCF and the GCD are the same. Okay, they mean the exact same thing. One is greatest common factor, one is greatest common divisor, but they really are just referring to the largest number that each number of a group is divisible by. Meaning I can take each number in that group and divide it by the GCF or the GCD and not get a remainder. Okay, so that's what those are. When I think about the LCM, it's the least common multiple. So the LCM is the smallest multiple of every number in a group. Okay, then the LCD is just going to be the LCM of the denominators. Okay, the LCD is specific to when we're talking about fractions, whereas the LCM can refer to any group of numbers that you want to talk about. Okay. So when we look for the LCM of 3, 21, and 36, we build it from the prime factorizations of those numbers. So 3 does not factor, okay? 21 is 3 times 7, and 36 is what? It's 4 times 9, so it's 2 squared times 9, which is 3 squared. So to build the LCM, I take each prime factor, okay, each one, and I throw it in the list, okay? And these numbers in this list are going to get multiplied together. There's an exception. If there's a duplicate prime factor, so a prime factor that occurs in more than one prime factorization, all I want to do is put the largest number of repeats, or the largest number of occurrences, if you want to say it that way, that will appear in any of the prime factorizations. So in other words, I have a 3 here, and 2 copies of 3, or 3 squared here. So because it's in more than one, I go with the largest number of repeats, or the largest number of occurrences. So when I build my LCM, I just put in 2, okay? Don't make the mistake of putting in 4. A lot of people say, okay, I got a 3 here, a 3 here, and then 2 3s there, so I'm putting in 3 times 3 times 3 times 3. No. Largest number of repeats between any of the prime factorizations is all you need. Then I have a 2 squared. I don't have it anywhere else, so I just put in 2 factors of 2. Okay, very simple. Then I have a 7. I don't have that anywhere else, so I just throw in a 7. Very, very simple to understand. Again, the only place where it can get confusing is if you have a duplicate factor, and again, you go with the largest number of repeats in any of the factorizations, okay? So now I just multiply the numbers on the list, and what would that give me? So 3 times 3 is 9, 9 times 2 is 18, 18 times 2 is 36, 36 times 7 is 252. So my LCM for the numbers 3, 21, and 36 is 252. So this is the smallest multiple for the group of numbers, right? So the smallest multiple that is a common multiple for 3, 21, and 36. Now, we can say that the LCD, because we're working with fractions here, right? And these are denominators. So the least common denominator is going to be equal to 252, okay? But if we were just working with the numbers 3, 21, and 36, we would not say the LCD, we would say the LCM because we're just talking about a group of numbers. Again, because these are fractions, we can say the LCD because we are specifically talking about the least common multiple for the denominators. Okay, so I want to make sure that's clear for you. All right, so let's look at a few examples here. We're going to make this a very quick lesson. So we have 5x squared minus 1 over x squared minus 1, and we have 2x minus 1 over x squared plus 2x minus 3. Don't worry about the numerators at all. We're just looking at the denominators. And all we want to do with the rational expression is just factor. okay? Just like we did with numbers. So what is x squared minus 1? That factors into the difference of squares. This is x plus 1 times x minus 1. What is x squared plus 2x minus 3? Let's go ahead and factor that guy. We know this is x and this is x. If this guy is a negative 3, that can only come from 1 times negative 3 or negative 1 times positive 3. So it's going to have to be positive 3 and negative 1, right? Because the middle term is positive. So looking at this guy, what's common? We have an x minus 1 here and an x minus 1 here. So to build the LCD, what do I need? I'm going to throw in everything, right? So x plus 1 goes in. X minus 1 is here and also here. Between the two factorizations, I've got a maximum of 1. So when I build my LCD, I only need to put in 1 copy, not 2. I realize it's in both, but if it's duplicate, you just put in the largest number of occurrences. In this case, it's only 1, okay? Please understand that. Then I've got my x plus 3, okay? So the LCD here is x plus 1 times x minus 1 times x plus 3. So that's all it is. All right, let's look at another one. So we have 2x squared minus 5x minus 1 over x squared plus x minus 30. We have 3x squared minus x minus 1 over x squared minus 10x plus 25. So again, all I'm looking to do is just factor the denominators here. So if I factored this guy, what would I have? X here and here. Two integers that sum to 1 and give me a product of negative 30. Well, that would give me positive 6 and negative 5, right? The outer would be negative 5x, the inner would be plus 6x, so that would give me my positive 1x. Then this guy over here is a perfect square trinomial. How do I know that? I've got something squared and something squared, right? 25 is 5 squared. So if I wrote this as x, which is what's being squared, you got a minus there, so minus, what's squared here? It's 5. So x minus 5 squared, right? You can check that middle term. 2 times x times 5. 2 times 5 is 10. 10 times x is 10x. So you have minus 10x there. So we're good to go. Now I'll probably want to expand this so it's crystal clear for you. So now what is the LCD? What is the LCD? Well, I've got x plus 6. Doesn't occur over here. I've got x minus 5. And that does occur over here. So I've got 1 here and I've got 2 here. How many am I putting in? Please don't answer 3. The largest number of repeats between this factorization and this factorization occurs here. I've got 2 of them. So just put 2 in when you build your LCD, okay? So I don't need 3. I can't stress that enough. So the LCD is going to be x plus 6. Then we're multiplying this by x minus 5. And then we're multiplying this by another x minus 5. Or to make this simpler, you can just write the x minus 5 part as squared. All right, let's just look at one more of these. I think it's very straightforward. And then in the next lesson, we're going to review how to add and subtract rational expressions. And we're going to use this kind of information or this knowledge right away. So we have 12x minus 5 over 3x squared minus 20x minus 32. We have 2x squared minus 7x minus 5 over 3x squared minus 2x minus 8. We have 5x squared minus 1 over x squared minus 4. So what's the LCD? What is the LCD? So let's start by factoring this guy. So I know I would have a 3x here and an x here. So I know I have a negative and a negative, so that means I have different signs. And I'm looking for a product of 32. Forget about the fact that it's negative. So what can give us a product of 32? We've got 1 and 32. And there's absolutely no way to make that work. You've got 2 and 16. That's not going to work. Then you've got 4 and 8, and we can make that work. If I put a 4 here, and I put an 8 here, the outer would be negative 24x, and the inner would be plus 4x, so that would give me negative 20x. That's what we're looking for. For this guy right here, I can factor this, so we would have 3x here and x here. So I'm thinking about what? I've got a negative 8, and so since this guy is negative also, I'm going to have alternate signs. So plus and minus, or minus and plus if you like it that way, it doesn't matter. Think about the factors of 8. You've got 1 and 8 or 4 and 2. So would 1 and 8 work? No, right? There's no way to make that work. So you would have to go to 4 and 2, and the correct combination would be to put a 4 here and a 2 here. So your outer would be negative 6x, and your inner would be plus 4x, so that guy's factored. So now down here we have x squared minus 4. So this factors into x plus 2 times x minus 2, right? This is basically x squared minus 2 squared, right? It's the difference of two squares. Okay, so now that we've got everything factored, we want to build our LCD. And so we've got a 3x plus 4, so let's put that in there. Now, it's in this guy and it's in this guy. So the largest number of repeats between any of the factorizations is 1. So it just goes in once. Then I'm going to have my x minus 8. That's not in any other factorization. I'm going to have my x minus 2, which occurs here and here, but only once in each, so I only need to put 1 in. And then I have my x plus 2. Okay? So for the LCD, we have 3x plus 4. This is multiplied by, you're going to have x minus 8. This is multiplied by x minus 2. This is multiplied by x plus 2. In this lesson, we want to review adding and subtracting rational expressions. So again, before we kind of jump in and look at some examples with rational expressions, let's refresh our memory by just working with some fractions, right? The rules are the same. So if we're adding fractions or subtracting fractions, and we already have a common denominator, we just work with the numerators, and we put the result over the common denominator, and then we simplify if we can. So if I have 1/7 plus 4/7, well then all I need to do is add 1 plus 4, because the denominator is the same. So 1 plus 4 is 5. Put that result over the common denominator of 7, so we get 5/7. Now, in this particular case, there's nothing to simplify, right? There's no common factor other than 1 between 5 and 7, so we report our result as just 5/7. Now, in the case where we don't have a common denominator, we need to first get a common denominator. Now, the easiest denominator to work with is the least common denominator. In the last review session, we talked about how to find the least common denominator. If you're a little bit confused about that process, please review that video before you move forward. But it's a very simple thing. Essentially, if I have 5/9 plus 2/15, to find the LCD, I want the least common multiple of the denominator. So I want the LCM of 9 and 15. And I just find that by factoring each, right? So 9 is 3 times 3, and 15 is 3 times 5. And all I want to do is put in each prime factor, right, from each of the factorizations. But I want to make an exception here. If I have something that's duplicated between more than one prime factorization, I only want to go with the largest number of repeats or the largest number of occurrences in any of the prime factorizations. So for the prime factor of 3, you see that you have 2 of them here, right? When you have the prime factorization of 9, you only have 1 of them here. So I only need to put 2 in when I build my LCM. I don't need 3, right? I just go with the largest number of repeats, which is this right here where I have 2 of them. Then I have a 5 here. It doesn't occur in the prime factorization of 9, so I just throw that in there. So 3 times 3 is 9, 9 times 5 is 45. So the LCD, or the least common denominator, is going to be 45. Now what do we do with this information, right? We don't just get 45 and then turn in the test. So the LCD of 45 is used to rewrite each fraction as an equivalent fraction where 45 is its denominator. So I'm going to say this is equal to, you have 5/9 times, what do I need to multiply 9 by to get to 45? Well, 45 divided by 9 is 5, so I'd multiply this by 5 over 5, right? Remember, you're just multiplying by a complicated form of 1 there. Then plus, you have 2/15. What do I need to multiply 15 by to get to 45? 45 divided by 15 is 3, so times 3 over 3, okay? So now 5 times 5 is 25, and this is, of course, over 45. Then plus 2 times 3 is 6, and this is, of course, over 45. And now it's just like the last example. We have a common denominator, so we just work with the numerator. So 25 plus 6 is going to be 31, so you get 31 over the common denominator of 45. Now, 31 over 45 is already simplified, so this is our answer. So now let's use the same thought process and do some addition with some rational expressions. So we start out with 7x over 5x plus 6, and then plus 2 over x minus 2. So if I look at my denominators to start, I have 5x plus 6, nothing I can do to factor, and then x minus 2, nothing I can do to factor. So if neither one of those is going to factor, the LCD is just going to be the product of the two. So the LCD will be 5x plus 6 multiplied by x minus 2. So to get a denominator here of 5x plus 6 times x minus 2, I just multiply by x minus 2, right? So multiply this by x minus 2. But I've got to also do that to the numerator so that it's legal. Okay? So all I'm doing, if I wanted to break this up to make it crystal clear, I'm just multiplying again by a complicated form of 1. X minus 2 over x minus 2, this can cancel and just be 1, right? It's a complicated form of 1, but it's still like multiplying by the number 1. I'm not changing anything, okay? So let's redo this. So this is times x minus 2. This is times x minus 2. Plus. Then for this one, it's the same thing. So we have 2 over x minus 2. X minus 2 needs to be multiplied by 5x plus 6. And so I've got to do that to the numerator as well. And then I'm good to go. So now I just need to do some simplifying. Let's scroll down. So I'm going to use my distributive property to remove the parentheses in the numerator. So 7x times x is 7x squared. Then 7x times negative 2 is minus 14x. Then plus 2 times 5x is 10x. Then 2 times 6 is 12. So plus 12. Now we have a common denominator here, so don't even worry about it. We're just going to write it over the common denominator. So we're just going to write this over 5x plus 6 and then multiplied by x minus 2. Don't even think about the denominator until the end. We're just going to work with the numerator. So 7x squared, nothing to combine with that. You have negative 14x plus 10x, so that's going to be minus 4x. And then you have plus 12. And again, this is over the common denominator of you have 5x plus 6 multiplied by you have x minus 2. Now, I can simplify this if I can factor the numerator and I can cancel one of those factors with something in the denominator, right? So is 7x squared minus 4x plus 12 something we can even factor? Well, let's think about it. So we'd have 7x and we'd have x. And I know that I would need what? I would need a last term of 12. So if this is positive 12 and this is negative, this would have to be negative and this would have to be negative. So could it work with 1 and 12? Could I do a negative 1 and a negative 12? Well, the outer and the inner would not work out. What about if I had a 12 here and a 1 here? Would that work? No, it would not, right? The outer and the inner would still not work out. If 1 and 12 don't work, you also have 2 and 6. But you can see, obviously, that wouldn't work either, right? 2 and 6, the outer is just too large in terms of absolute value. And if you flip it around, it's the same. And then lastly, you have 3 and 4, but that's not going to work either, right? You can put 3 here and 4 here, or you could switch to 2. Either way, it just doesn't work, right? They're going to be too large in terms of absolute value to ever work out. So this guy right here is a prime polynomial. 7x squared minus 4x plus 12 is not going to be able to be factored using rational numbers. So this is as simple as we can make our answer. We have 7x squared minus 4x plus 12 over the quantity 5x plus 6 times the quantity x minus 2. And we leave our denominator in factored form just to show that we can't cancel anything else, right? We're just going to leave it that way. All right, what about 5x over x plus 5 minus 2 over x plus 8? So again, we have a scenario where we have x plus 5 that's not going to factor and x plus 8 that's not going to factor. So my LCD will just be the product of the two denominators. So x plus 5 multiplied by x plus 8. Okay, very simple. So what am I going to do here? I'll have 5x multiplied by the x plus 8. And this is over, you'll have x plus 5 times x plus 8. And then we have minus. You have 2 that's going to be multiplied by x plus 5, that quantity. And then this is over, you have x plus 5 times x plus 8. Okay? The main thing here, or the main mistake that you might make, ensure that you use parentheses around these guys because you've got to distribute everything. Okay? Very important to remember that, otherwise you're going to get the wrong answer. So let me put equals here and equals here. And let's kind of continue. So 5x times x is 5x squared. 5x times 8 is plus 40x. Now you have minus here. So let me put minus, and I'm going to put some brackets here because when you subtract something away, you've got to subtract away each term. Okay? So let's just go ahead and distribute. 2 times x is 2x, and then 2 times 5 is 10. So now I can remove these brackets here by changing the sign of each term. A lot of times you see people put this plus negative 1 to remind themselves to distribute the negative 1 to each term or just to change the sign. So this would be minus 2x and then minus 10. So minus 2x and minus 10, and this is over my common denominator of x plus 5 multiplied by x plus 8. Okay, let's get some room going. So we have 5x squared, nothing to combine with that. 40x minus 2x is 38x. And then you have minus 10, and this is over. You have x plus 5, this quantity, times x plus 8, this quantity. So this is as simple as we can make this. This guy right here, I spent the time to show you that the kind of first example, the numerator couldn't be factored using rational numbers. It's going to be the same thing with this one. This is a prime polynomial, the 5x squared plus 38x minus 10. So this is as simple as we can make this. All right, for the last one, we have 7x over 5x plus 5. Then plus we have 3x over x squared minus 1. Then minus 2 over x minus 1. So what we want to do again is first find the LCD. So if I factor the denominator here, I get 5 times the quantity x plus 1. If I factor the denominator here, this is the difference of two squares. This would be x plus 1 times x minus 1. And then this guy is not going to factor. It's just going to be x minus 1. Okay. So to build the LCD, I have a 5 here, no 5 in any of the other ones, so I'll put a 5 down. I have an x plus 1 here. I also have an x plus 1 here, but between the two factorizations, there's only one copy in each, so I only need to put one copy in my LCD. Then I have an x minus 1, and again, between these two factorizations, there's only one copy, so I only need to put one copy in when I build my LCD. So now, let's go ahead and write each of these with their denominator in factored form. So this is 7x, this is plus, this is 3x, this is minus, this is 2. Okay. So what would I need in this case to get a denominator of 5 times the quantity x plus 1 times x minus 1? Well, I would need to multiply this by x minus 1 over x minus 1. So let me kind of slide this down. And let me get a little room going here. So I'm going to put 7x times, I need to multiply by x minus 1. And this is over 5 times the quantity x plus 1 times the quantity x minus 1. And plus, for this one, I'm missing a 5, right? I have the x plus 1 part, I have the x minus 1 part, I just need the 5. So 3x times 5, this is over 5 times the quantity x plus 1 times the quantity x minus 1. Then minus, over here, I'm missing the 5 and the x plus 1. So 2 times 5 times the quantity x plus 1. Then this is over, again, 5 times the quantity x plus 1 times the quantity x minus 1. Okay. So from this point on, it's very simple. Let's kind of scroll down, get some room going. So we'd have 7x times x, which is 7x squared. Then 7x times negative 1 is minus 7x. And then plus 3x times 5 is 15x. Now you have this minus here. Whenever you're subtracting away something like this, again, just put a bracket out in front just to remind yourself that you've got to subtract away everything, right? You're subtracting away each term from this guy. So in other words, you're going to have 2 times 5, which is 10. Let me go ahead and just write this as 10. So you're going to have 10 times x, which is 10x, and then 10 times 1, which is 10. So you've got to subtract away the 10x and the 10. So in other words, you can put plus negative 1 here and distribute this to each term to remind yourself to remove the brackets and change the sign of each term. So this first guy would be negative 10x, and this guy would just be negative 10. Okay, so this is all over. Again, that common denominator of 5 times the quantity x plus 1 times the quantity x minus 1. Okay. All right, so now we have 7x squared and nothing to combine with that. We have negative 7x plus 15x, which is going to give us 8x, and then minus 10x, which is negative 2x. And then you have minus 10. Okay. And this is over. You have 5 times the quantity x plus 1 times the quantity x minus 1. Now, this is as simple as you could make this because, again, this trinomial here is prime, right? You're not going to be able to factor it using rational numbers. In this lesson, we want to review complex rational expressions. So back when we studied fractions, we learned about complex fractions. Complex fractions have another fraction in their numerator, or it could be in their denominator, or it could be both in the numerator and denominator. So when we come across the topic of algebraic fractions or rational expressions, we get the same thing, right? We just call them complex rational expressions. but they follow the same rules that we learned, again, with complex fractions. So to simplify them is very, very simple. There's basically two different methods you can use, one that I would consider to be a little bit slower and one that's a lot faster. So if I have something like 6 minus 5 over x, and this is over, we have 1 plus 5 over x. Let's first just identify the numerator of this complex rational expression, just so we can refer to it. So this is our numerator, and this guy down here will be our denominator. So you can think about this part right here, this fraction bar, as our main division. Okay. So we've got our numerator, our 6 minus 5 over x. We've got our main division, or our main fraction bar. And then we've got our denominator, our 1 plus 5 over x. So the first method to simplify this, kind of the slower way to do this, is to simplify the numerator and the denominator separately, and then perform the main division. So in other words, I can say 6 minus 5 over x is equal to what? Well, if I get a common denominator here, I would just multiply 6 by x over x. So 6 times x over x minus 5 over x would give me what? This would be 6x minus 5 over the common denominator of x. So that's my simplified numerator. So let's erase this, and we'll kind of drag this up here. Now for my simplified denominator, we have 1 plus 5 over x. So 1 plus 5 over x. To get a common denominator, I would just multiply 1 by x over x. So we know that would just be x over x. And then I would basically have x plus 5 over the common denominator of x. Okay, so let's write x plus 5 over the common denominator of x. So what do we have here now? We have 6x minus 5 over x divided by x plus 5 over x. So essentially, because this is the main division, again, I've already labeled that, you could really write this as 6x minus 5 over x divided by x plus 5 over x. So that makes it crystal clear what you need to do. You need to take this guy right here and multiply it by the reciprocal of this guy right here, okay? So I would say this is equal to, let me kind of scroll down just a little bit. We'd have 6x minus 5 over x times the reciprocal of this, which is x over x plus 5. And what's going to happen is I can cross cancel this x with this x, and I'm just left with 6x minus 5 over x plus 5. So 6x minus 5 over x plus 5. So that is the simplified version of this guy right here. So that's method one. That is kind of the slower way to do things. The faster way is to multiply the numerator and denominator of the complex rational expression by the LCD of all fractions involved. So this one's pretty simple. If I look through, I only have this fraction, and they're the same, right? So the denominator here is x. The denominator here is also x. So the LCD will just be x. So essentially what I'm going to do, let me just rewrite the problem down here. So 6 minus 5 over x over 1 plus 5 over x. I'm going to multiply this guy by x over x. Again, that's legal because x over x is nothing more than just 1. So let me scroll down and get some room going. I'm going to use my distributive property here, and I'm going to distribute the x to each term. So what this would be equal to, I would have 6 times x minus, I would have 5 over x times x. So we know this x would cancel with this x, and I'd essentially have 6x minus 5. This is over. I'm going to do the same thing over here. I'm going to multiply this by this and by this. So you would have 1 times x, or just x, and then plus, you would have 5 over x times x. We know that we can cancel this x with this x, and you would just have a 5 there. So look how quick we got the same answer. We get 6x minus 5 over x plus 5. Again, the LCD method is much quicker in almost every scenario. So for all the problems we're going to look at after this point, we're just going to use that method. All right, let's go ahead and take a look at another one. We have 1/3 minus 3 over x minus 2. And this is over x minus 2 over 36. And then minus, we have x plus 6 over x minus 2. So again, the idea here with the LCD method is to find the least common denominator of all the fractions involved. So you have a 1/3, a 3 over x minus 2, an x minus 2 over 36, and an x plus 6 over x minus 2. So I've got a 3 and x minus 2, a 36, and an x minus 2. So what would be the LCD here? Again, it's the LCM of these individual polynomials. So if you looked at 3, x minus 2, 36, and x minus 2 again. So I know that 36 divided by 3 is 12. So essentially it would just be what? It would be 36 times x minus 2. That would be the LCD. So my LCD is 36 times the quantity x minus 2. Okay, very easy to find. Now all I want to do is just multiply the numerator and denominator by the LCD. So 36 times the quantity x minus 2 over 36 times the quantity x minus 2. Now this will be a little bit more tedious than the last example. So when you do these, expect to have a lot of kind of scratch work. So again, I'm going to distribute this to each term here. So the 36 part multiplied by the 1/3 part, if I just do this off to the side, you can see 36 would cancel with 3 and give me a 12, right? So this would basically turn into a 1. This is a 12, so you'd have 12 times the quantity x minus 2. So we would have 12 times the quantity x minus 2, then minus. Next, you'd have this guy times this guy. So you can see that this x minus 2 here would cancel with this x minus 2 here, okay? So what that would give me is what? Just 36 times 3, which is 108, okay? Now, obviously, we can simplify this further, but let's just go ahead and distribute down here first, and then we'll come back. So if this gets distributed to this, the 36 here would cancel with the 36 here. You would have x minus 2 multiplied by x minus 2. So in other words, you would have x minus 2, this quantity squared. Then you have minus. If this multiplies by this, the x minus 2 would cancel with the x minus 2 there. And essentially what I would have is 36 times the quantity, x plus 6. Okay? So now that we've set this up, let's kind of scroll down. And we're just going to simplify now. So in my numerator, 12 times x is 12x. And then minus, you have 12 times 2. 12 times 2 is 24. So minus 24. And then you have minus 108. Okay? So I'm not done up here. I can still simplify. If I have negative 24 and I subtract away 108, I'm going to get negative 132. So I'm going to write minus 132. And then down here, I have x minus 2, this quantity squared. So I know that would be x squared minus, you would have 2 times x times 2, so basically minus 4x, and then plus, you'd have 2 squared, which is 4. Then for this part right here, we need to pay close attention to the sign. I'm subtracting away this whole thing. The easiest way to do this and not make a sign mistake is write this as plus negative 36 and distribute the negative 36 to each term there, okay? So negative 36 times x would be negative 36x. And then negative 36 times 6 would be minus 216. Okay? So now we want to simplify here. X squared, I don't have anything I can combine with that. Negative 4x minus 36x is negative 40x. So let's write this as minus 40x. And then if we have 4 minus 216, that's going to be negative 212. So this is minus 212. And now we want to see if we can simplify by factoring the numerator and denominator and canceling any common factors. So in the numerator, I can see that I can factor out a 12, right? 132 is 12 times 11. So I can pull out a 12, and I would have x minus 11 inside the parentheses. Down here, can I factor this guy? Can I factor x squared minus 40x minus 212? Well, if I can, I would set this up as x and x. I would need 2 integers such that the sum is negative 40 and the product is negative 212. So what are the factors of just 212? Forget about the signs. So 1 and 212, you've got 2 times 106. And then you've also got 4 times 53. Now 53 is a prime number, so you really can't go any further than that. So would any of these work? Now keep in mind that you have to have opposite signs because this guy is negative and this guy is negative. So one of these would have to be plus and one of these would have to be minus. Well, 1 and 212, no way you could make that work. 2 and 106, no way you can make that work. And then 4 and 53, also no way to make that work. So this guy right here is a prime polynomial, so it can't be factored using rational numbers. So let's go ahead and erase that, and we'll just write this over x squared minus 40x minus 212. So this is as simple as we can make this. We'll just leave the numerator in factored form, because that's typically what we would do. All right, let's take a look at another one. So we have 1/2 plus x plus 4 over 4. This is over x minus 5 over 2 plus x plus 4 over x minus 5. So what's the LCD? We have a 2, we have a 4, another 2, and an x minus 5. So between 4 and 2, we know it's going to be a 4, right? 4 is 2 copies of 2. So in all the prime factorizations, you would have just a 2, and then 2 copies of 2. So that would win out. And then you have this x minus 5. So the LCD would be 4 times the quantity x minus 5. So I'm going to be multiplying that by both the numerator and the denominator of the rational expression. So I'm going to multiply this by this, and also this by this. So when I start out, 4 times the quantity x minus 5 multiplied by 1/2, the 4 would cancel with the 2, and this would become a 2, right? So essentially I would have 2 times the quantity x minus 5, then plus, when this multiplies this, my 4 here would cancel with my 4 here. So I would have x minus 5, that quantity, multiplied by the quantity x plus 4. All right, so down here, I'm going to do the same thing. I'm going to distribute. So I'll put this over. 4 times the quantity x minus 5 multiplied by x minus 5 over 2. The 4 would cancel with the 2 and give me a 2. So you would have 2 multiplied by the quantity x minus 5 squared, right? X minus 5 squared. If you wanted to write x minus 5 times x minus 5, that's fine too. Then for this guy, we'd multiply. In this particular case, you would have the x minus 5 here cancel with the x minus 5 here. And so you would have plus 4 times the quantity x plus 4. Okay? All right, let's get some room going. And now we just need to simplify. So 2 times x is 2x. Then minus 2 times 5 is 10. Then plus. If we have x minus 5, this quantity multiplied by x plus 4, that quantity, x times x is x squared. The outer would be 4x. The inner would be minus 5x. So that's minus x. Then the last, negative 5 times 4 is minus 20. So we would simplify this as x squared. The 2x minus x would be plus x. And negative 10 minus 20 is minus 30. Okay? Let's erase this. And we'll just drag this up. All right, then this is over. For this guy right here, I have 2 multiplied by the quantity. X minus 5, that amount squared, we follow our formula. It's x squared minus 2 times x times 5, so minus 10x. And then plus this guy squared, which is 25. If I multiply 2 by each term here, this would be 2x squared. This would be minus 20x. And this would be plus 50. Okay. Then plus, you have 4 times x, which is 4x. Then plus, you have 4 times 4, which is 16. So what can I do here? You have 2x squared, nothing to combine with that. You've got negative 20x and 4x. That would give me negative 16x. Then you've got 50 and 16. That would give me 66. Let me kind of slide this down so it matches up. Okay, so what can we do here to factor? In the numerator, I need 2 integers that are going to sum to 1 and give me a product of negative 30. That would be positive 6 and negative 5. In the denominator, I know I can pull out a 2 to start. So that would give me x squared minus 8x plus 33. Now, if we want to factor the inside here, the x squared minus 8x plus 33, we would need what? Let me just write that over here. We would have x and x. The middle term is negative and the final term is positive. So you would need a negative and a negative. Now, is there any way to get that with the last term of 33? No, there isn't. Because the factors of 33 would be 1 and 33, or it could be 3 and 11. Now, you might look at 3 and 11 and say, oh, well, if I had a negative 11 and a positive 3, but the signs have to both be negative, so that doesn't work, right? You could only do a 3 here and 11 here. Both are negative. That would combine to give you a negative 14x, so that wouldn't work, right? So this guy's going to be a prime polynomial. So this is as simple as we can make this. We have our quantity x plus 6 times our quantity x minus 5. This is over 2 times the quantity x squared minus 8x plus 33. All right, let's take a look at one more of these. So we have x minus 2 over y plus 1. Then we have x plus 4 over y plus 1. This is over, we have x plus 1 over x plus 4, then minus x minus 2 over x plus 4. So in this case, we have a denominator of y plus 1, and we have a denominator of y plus 1, a denominator of x plus 4, and a denominator of x plus 4. So the LCD would be x plus 4 times y plus 1. Okay. And again, I'm just going to distribute this to each term here. So for this guy, the y plus 1 would cancel with the y plus 1, and I would be left with x plus 4 multiplied by x minus 2. And then minus, when I distribute it here, the y plus 1 would again cancel with the y plus 1. So now I would have x plus 4, this quantity squared. This is over. Down here, when this gets multiplied, in each case, the x plus 4 is going to cancel, right? So I would just have the x plus 1 multiplied by the y plus 1. And then minus, again, this is going to cancel with this. So you would have your x minus 2 multiplied by your y plus 1. All right, so to simplify in the numerator, we'd have x times x, which is x squared. The outer would be minus 2x. The inner would be plus 4x. So this is plus 2x. The last would be minus 8. Then this is minus. For this guy right here, you got to be very careful. You're subtracting away this whole thing. You've got that minus out in front. And there's no way to really distribute that yet until you kind of do your FOIL on this. So go ahead and put a bracket here and then FOIL this out or use your special products formula. This is x plus 4 squared. So we would have x squared, then plus 2 times x times 4, so plus 8x, and then plus 4 squared is 16. So now I can subtract each one of these away, right? So you think about that as just distributing the negative to each term. A lot of people do plus -1 here, and then again, they just distribute this to each term, just to make it crystal clear what's going on. So I'm going to erase all this, and I'm just going to change the sign of each term. So this is minus, and this is minus. So x squared minus x squared is 0, so that's gone. 2x minus 8x is going to give me negative 6x. So this would be negative 6x over here. And then negative 8 minus 16 is minus 24. So negative 6x minus 24. Then this is over. For this guy right here, you have x times y, which is xy. You have an outer, which is plus x. You have an inner, which is plus y. And then you have a last, which is plus 1. Then again, I'm minusing this, so put a minus, put some brackets, go ahead and do your FOIL, and then again, distribute the negative to each term. This whole thing is being subtracted away. Very important you understand that. So x times y is xy. The outer would be x times 1, which is just plus x. The inner would be negative 2 times y, which is minus 2y. And the last would be negative 2 times 1, which is minus 2. So what can we do here to simplify? I'm going to distribute this negative to each term. So essentially, I'm just going to change the sign of each term. So this will become negative. This is negative. This is positive. This is positive. Okay? Again, I can't stress this enough. Very important you do that. Otherwise, you will get the wrong answer. So xy minus xy is 0. So those are gone. You have x minus x. That's 0. So those are gone. You have y plus 2y, which is 3y. So we can erase those. And you have 1 plus 2, which is 3. So what I want to do now is try to see what I can cancel between the numerator and denominator. I'm just going to factor this guy. So in the numerator, I can pull out a negative 6, or I could pull out a 6. Let's just go ahead and pull out a negative 6. And that's going to leave me with an x plus 4 inside of the parentheses. Then in my denominator, I have 3y plus 3. I can pull out a 3 there. And I'd be left with a y plus 1 inside the parentheses. So now I can see that I can cancel between this negative 6 and this 3, right? I can cancel this with this. 6 divided by 3 is 2. So this is basically a negative 2 right there. So I can write this as negative 2 times the quantity x plus 4 over, you can write the quantity y plus 1 in parentheses or just y plus 1. Doesn't really matter. So we see we have a simplified answer here, nothing else we can cancel. Again, you've got -2 multiplied by the quantity x plus 4 over y plus 1.